inverse. Mathematics students will be very sincere. Generally, there are some characteristics for mathematics students. So very hardworking, straightforward, is it not? Oh, outspoken. All these are characteristics. So directly you start doing the question. But you should not do like that. You should be smart in the entrance. So you start finding P inverse. This is a 3 by 3 matrix. Finding P inverse is adjoint A by det A. It is not so easy. So there is some shortcut. So what is the shortcut? Product of eigenvalues. Just now I told you what is the relation between product of eigenvalues and the determinant. What is the product of the eigenvalues?
Determinant of
Product
A.
of the product of the eigenvalues is nothing but determinant. So product of eigenvalues is equal to whatever may be the matrix. Eigenvalues of P inverse is equal to det of P inverse. What is det of P inverse? 1 by det of P. Because det A inverse is 1 by det A formula. So you know how to find determinant of this matrix. It is easy to find determinant of this matrix. So how to find determinant of P? Expand along first column. If you expand along first column, you get 1 into, that is -5 -6, remaining zeros, is it not? Expand along the column, -3 4. This is -20 plus 18. This is -2. Is it not? So because I'm expanding along column, 1 into, you know how to find out, 3 by 3 determinant. 0 into anything is 0, 0 into anything is 0. So if I do it, you may feel I am underestimating you. So this is, you know how to expand the determinant. This is -2. Now apply this 1 by -2. So what is product of the eigenvalues? What is the answer for this? 1 by -2. That is -1 by 2 is the answer for this question. So simple. But you should know what is the relation between eigenvalues and we have used two properties. What are the two properties we have used? One formula we have used is product of eigenvalues is equal to determinant. First formula. Second formula is the relation between determinant of P inverse and det P. What is the relation between them? That is determinant P inverse and det P. Relation is okay. So using these two, we could answer this question. Next, is it okay? Next, shall I go to next bit? Yes or no?
Yes, madam.
Yes. Okay, fine. So here you can see another question. M is equal to 1 by 4, 3 by 4, 2 by 5. I think 3 by 5 and 2 by 5. If I is the identity matrix and 0 is the 0 matrix, then which of the following is true? This is the question. So then if you are very sincere, then what you will do? You will find out M square, you will find out, you will substitute in this and verify which is correct. This is direct method. But whenever such equation is given, you should remember that you have to go for characteristic equation. Don't do it directly. But finding characteristic equation is worse because it is in fractions. So first we'll try to eliminate these fractions. So it is not a crime if you find out M square and substitute, but it's time taking. So what we observe is here.
Can erase that, man.
Yeah, I'll erase this. Shall I erase this? No problem. If this space is sufficient, okay. Otherwise, I'll erase. So, you want me to do this question somewhere else? In the next. So, M is equal to, in the class I will do on the empty screen. Don't worry. But because we are doing for the demo sake, I'm doing here. So 2 by 2, 5. This is the one. Now, first we have to convert. Eliminate frac. How to eliminate this? Any one of you? Do you have any idea? Yes, ma? Any idea?
Yes, ma.
Using the LCM.
LCM, correct, good. So what is the LCM of this 4 and 5 is? 20. So multiply by 20 so that these fractions will get eliminated. Is it not? These fractions
Will be eliminated.
Yeah. They'll get eliminated and you get 20m. But you have to multiply on both the sides. Whenever you are multiplying, this multiplication you have to do on both the sides. Is it not? So let us do on both the sides. Multiply by 20m. So when we discuss, you can copy later. Okay. This is only for demo sake. Adjust with my handwriting, and if there is speed, for example, you please raise your hand. I'll understand that I'm going a bit fast. So 20m. Let us multiply. So let us multiply by 20. What is 20m is equal to? Each and every term I'll multiply by 20. So 20 by 4. This will be, this is 60 by 4. This will be again 20, no? 60 by 5. Multiplying by 20. This is 40 by 5. So this will reduce to 5, 12, 12, 8. Is it not? Hope I did not do any mistake. Yeah,
Madam,
this is the one. Amma?
5,
It is 5, 15, 12, 8.
15.
Yeah, 5.
5, 15.
Sorry, I'm sorry. 5, 15. Here it is 12. And again 8. Correct, no? Hope no mistake.
yes,
Yes, ma'am. Yes.
Yes, no? Yeah, no mistake. We should be careful because again, we are going to do this characteristic equation for this. 20m you find out. What is the characteristic equation for 20m is, this I will call it as some matrix A. So determinant A minus lambda equal to 0. So what will you get? Determinant A minus lambda equal to 0 for this. 5 minus lambda, 15, 12, 8 minus lambda. I think I can run here. So 5 minus lambda into 8 minus lambda minus, here we'll get 180 is equal to 0. So now if you simplify this, you will get lambda square minus 8 lambda minus this is minus 13 lambda. 40 minus 180 is minus 140 is 0. This is the characteristic equation for A. What is A? 20m. You have a theorem called Cayley-Hamilton theorem. What is Cayley-Hamilton theorem? Every matrix satisfies its characteristic equation.
Own characteristic equation.
Characteristic equation. So what is the matrix? A is the matrix. Which will satisfy? A will satisfy. Is it not? So what is by Cayley-Hamilton theorem? What will you get here? Here you will get by Cayley-Hamilton theorem A square. Here we have to substitute A square. A square minus 13. You don't substitute m. Some students they substitute m. This is characteristic
20.
equation for A. What is A?
20m.
So this is characteristic equation for this matrix. What is this matrix? This is not m. This is A. What is A? 20m. So every matrix satisfies its characteristic equation by Cayley-Hamilton theorem. Replace lambda by A, and whenever constant is there, we replace it by constant times I, because there is no concept of subtracting a number from the matrix. Now in place of A, substitute 20m. So if you substitute 20m from this, what will you get? 20m whole square. 13 into 20m. Because I am explaining, it is taking time. For you, it should not take that much time in the examination hall. Now this is 400m square. This is 13 into 20m. I'll keep it as 20 square. 20 square m square, 13 into 20m minus 7 into 20 is equal to 0. So 20 can be cancelled. You get 20m square minus 13m minus 7i is equal to 0. Now you can see this may be there among the options. 20m square minus 13m minus 7i. 20m square minus 13m minus 7i. So which option correct? B option is the correct option. So whenever such questions are given, don't do it. Don't do hard work. Do smart work. Try to escape. So whenever such questions are given, that means there is some shortcut behind it, some common sense. How you are getting shortcuts? Experience and common sense. That's the only trick. So how we are getting it? Because it is a very like fractions are there. We want to multiply, eliminate this. How to eliminate? Take LCM of the denominators. So 20m. And so we got this matrix. Find out characteristic equation. Replace lambda by a. Take care there. So then otherwise you may be given m square minus 13m minus 140i equal to 0. That may be there among options. If I am given chance to set the paper, that will be the first option. First I will give m square minus 13m minus 140i equal to 0. 90% of the students will fall into that option. M square minus 13m minus 140i. Because you will, after doing up to this, you will not remember is it A or M. You remember only one matrix given as M. So first option will be that only. So you will be so tempted. And first option you will mark. So be careful. This is characteristic equation not for M. This is for A. A is 20m. Later you substitute. This is the bit. Okay. Similarly, another application of Cayley-Hamilton. Generally, Cayley-Hamilton theorem means all of us know every matrix satisfies its characteristic equation. That is some 15 marks question in some universities, in some universities 20 marks. You pass the exam only because of Cayley-Hamilton theorem. Is it not? That is, when it is given, you feel so happy application. But it is like very lengthy. That you should not do here. You have to do application like this. Okay, I hope it is clear. Shall I go to next one, ma? Same Cayley-Hamilton.
Yes, sir.
So how
Yes.
you are going to get question? Application of Cayley-Hamilton in the exam. You should get this idea. Getting the idea is very important. How you get? Only by practice. When you practice and attend classes, you will come to know these tricks. Like how I'm, question is the same. You will not find in any, even this paper guide is there, some like worked out papers are there. You find generally in the worked out papers, shortcuts will not be given, and they cannot be, everything cannot be written. That is the main problem. Some guidelines you get directly from the teacher. Everything cannot be like scripted. Is it not? That is not possible. So while attending the classes, you will come to know how I am handling the question. So what is the idea behind it? Next time if you get this, automatically you will get this idea if you practice. Array, madam told this in the class. So maybe this trick works. It's only trial and error in the entrance exam. So you can apply and know the trick. So just apply that, you may get the answer. We don't know. But next one, sure. Look at, you can see. I think I can move to next question. You can see if P is equal to this matrix and 6P inverse is AI3 BP minus P square, then the ordered pair A comma B is, we are asked to find. So how to find out? Let us see. Whenever you get P inverse, don't find P inverse. It is 3 by 3. Remember, Cayley-Hamilton. So what is Cayley-Hamilton theorem? Every matrix satisfies its characteristic equation. So find out what is the characteristic equation of P. From there, find out P inverse and then equate. Then you get the ANG value. Let us see. So this is determinant. Let us apply for this characteristic equation. So what is the characteristic equation for this? 1 minus lambda, 0, 1. This is 0, 2 minus lambda, 1. This is 2, 0, minus 1 minus lambda equal to 0. Okay. Now, let us try to expand. Expand along any row or any column. Option is yours. So 1 minus lambda into, I am skipping the steps. So this is 2 minus lambda into minus 1 minus lambda. All of you know how to expand the determinant. Closing this, AD minus BC. 0 into anything 0 plus 1 into, again, close this row, this column, 0 minus 2 into 2 minus lambda is equal to 0. Now take 2 minus lambda common. Later we can minus sign also common here. 1 minus lambda into, wow, this simplification is your option. This is minus 2 into 2 minus. How you simplify is your headache. Towards end, we should get the same answer. So 2 minus lambda into 1 minus lambda square. Here minus I have taken common. This will become plus 2. So minus of 2 minus lambda minus 2 plus lambda. This is 3 minus lambda. So if there are any mistakes, please tell me. This is minus lambda cube. This is plus 2 lambda square plus 3 lambda minus 6 is equal to 0. So now, what is the characteristic equation? This. You know, every matrix satisfies the characteristic equation. So P satisfies. 2P square, 3P minus 6i, 0. Now, take 6 to other side. 6i is equal to minus P cube. Why I am taking? Because if you remember the question, we are having 6 on the right side. So that is the reason I am keeping 6i on one side and remaining on the other side. Now we want P inverse. So operate P inverse. Multiply by P inverse. So P cube into P inverse is P square. P square into P inverse is P. P into P inverse is I. I'm multiplying by P inverse. So 6P inverse is equal to minus P square plus 2P plus 3i. I have skipped some steps. Multiplied by P inverse. P into P inverse is I. That's how I got it. But what is the answer we got? We are given this to be equal to 6P inverse is equal to this part. That is A into I3 BP minus P square. AI3 plus BP minus P square. AI3 BP minus P square. This is what is given for us. So equate them. So I3 coefficient, I means I3 only, A is equal to 3, comparing I coefficient. What is B is P coefficient 2. So what is A comma B? Ordered pair 3 comma 2. So go back. Are you asked to find A comma B or B comma A? That also you have to take care. So here you are asked to find A comma B 3 comma 2. Sometimes wantedly, just to tease you, you may be given B comma A. So after doing so much, you will not remember whether A comma B or B comma A. So you will write 2 comma 3. So you should be very, very careful. So if it is B comma A, 2 comma 3 is correct. If it is A comma B, 3 comma 2 is correct. So be careful. 3 comma 2 is there, 2 comma 3 is also there. 4 comma 5 is there, 5 comma 4 is. If you do any mistake anywhere, you will get this answer. In the calculation, if you do calculative mistake anywhere, you will get one of these options. Again, A comma B or B comma A. Based on that, you are given. So be careful. Please check again whether it is correct or wrong. Because everything appears to be correct on the screen when we are near the screen or near the board. Everything appears to be correct because you are far, you are not in near that. So you will know correctly. Okay, please, if there are any mistakes, look at this question. Please message, or you can unmute and speak. You can see another question. Are you interested? Do you want me to continue? Emma,
Yes, ma'am. Yes, ma'am.
are bored? Getting bored?
No, ma'am.
No, okay. So, and many are there. You can see, yeah, coming from the option is another model. Here, I will answer this. The eigenvalues of the matrix are. If we don't have shortcut, what you will do? Very sincere, no? As I said, being max students, very sincere. That too, 2 by 2, very tempting. Characteristic equation you will find out, and eigenvalues you will find out. It is not a crime, but waste of time, space problem will be there. So instead, you can do one thing. Whenever such questions are given, luckily you are asked to find what are eigenvalues. So what we will do is, what is the relation between eigenvalues and matrix? Sum of eigenvalues is equal to trace. Trace. What is trace of the matrix? 3 plus 2, sum of the principal diagonal elements, 5. But 3 comma 2 are not eigenvalues. Some students, they have a misconception. Principal diagonal elements are the eigenvalues. But it is not correct. Principal diagonal elements are not the eigenvalues all the time. They are the eigenvalues when the matrix is upper triangular and lower triangular or diagonal. Then only principal diagonal elements will be the eigenvalues, not all the time. So because of a lack of clarity, some students, they may answer 3 comma 2 as the eigenvalues, keeping that in the mind. So sometimes the teacher might have told you principal diagonal elements are the eigenvalues in case of upper triangular. So lower triangular or diagonal. So because of that, they may write 3, 2. Incorrect. So be careful. Sum of the eigenvalues is 5. Sum equal to 5 does not mean 3 is one eigenvalue, 2 is another eigenvalue. Sum is 5. So you got same total as your friend in the TSET exam or a DL exam. It does not mean you scored same in each and every paper. In 2 paper, you might have got some, and 3 paper different. 2 and 3 scores may be different, but total may be same. Total same does not mean individually same. So similarly, the total sum of eigenvalues is equal to sum of diagonal elements does not mean diagonal elements are the eigenvalues. That misconception you have to remove from your mind. So this is the one. If at all they are the eigenvalues, when you add them, you should get 5. And product of eigenvalues is equal to det A. What is det A? Determinant of this 6 minus 72, which is minus 66. This is AD minus BC, minus 66. Now, if at all this is correct, then when you add, you should get back trace A. When you multiply, you should get back minus 66. When you look at it, when you add them 3 plus 2, 5, matching, sum of eigenvalues is 5, don't jump up. Both should be satisfied. So most of the students, intelligent students, they fall under this option. Why? Because sum of eigenvalues 3 plus 2, 5 matching, but second also should be satisfied. So here also 1 plus 1, 2, not satisfying. So this cannot be the correct option. This cannot be the correct option. Why? Because product of eigenvalues 3 2s are 6, but product should be equal to minus 66. So this is not correct. When you look at it, when you add them, 11 minus 6, 5. So 11 plus minus 6, 5. 11 into minus 6, minus 66. It is satisfying both. This is the correct option. Some students, they may be tempted. When you multiply, you are getting minus 66, correct. But when you are adding 6 minus 11, you are getting it as minus 5. But you should get it as 5. Sum of eigenvalues is not equal to this. Therefore, this is incorrect option. So otherwise, these two are again tempting. Out of this, choosing correct option is very important. Product is same, but sum is not same. Here, sum is same, but product is not same. So be careful. This is the right answer. This is how you have to come from the option model. Okay. Next. Here you can see the inverse of the matrix is. Any one of you got the idea how to do this? Is this okay, ma? Previous bit?
Okay.
Yes, madam.
Okay, good.
Using Cayley-Hamilton theorem.
Using Cayley-Hamilton theorem.
9 to 1 is done using Cayley-Hamilton theorem.
You can find inverse.
In finding inverse, Cayley-Hamilton theorem, correct, good. So for this, now you have come into the track. So inverse means whenever I said Cayley-Hamilton, so you catch it that point. So you have to apply this Cayley-Hamilton theorem. So find out the characteristic equation. This is upper triangular. What are the eigenvalues? 2, 5, 4. Why upper triangular? This is the principal diagonal. What is in the upper triangular? The elements below the principal diagonal, if they are 0, then it is called upper triangular. Above 0, then it is called lower triangular. Above 0 as well as below 0, then it is called diagonal. So when the matrix is upper triangular or lower triangular or diagonal, eigenvalues are nothing but the diagonal elements. So what are the eigenvalues here? 2, 5, 4. So how to find characteristic equation? 2 models. So lambda is equal to 2 is an eigenvalue, lambda equal to 5 is eigenvalue, lambda equal to 4 is eigenvalue. That means lambda minus 2 into lambda minus 5 into lambda minus 4. If you do, you will get the characteristic equation. That is one way. Or if you want to go using your original method, you'll get the same answer. Subtract diagonal is lambda. This is 1, 4, 0, 5 minus lambda, 3, 0, 0, 4 minus lambda. Determinant equal to 0. Then 0, 0, 4 minus determinant. How will you find? This is upper triangle. Upper triangular matrix or lower triangular or diagonal. Determinant is nothing but the product of the eigen, product of the principal diagonal elements. How to find determinant for upper triangular? Product of the principal diagonal elements will directly give you the determinant for lower triangular, upper triangular, or diagonal. So you will get same using eigenvalues. 2 is eigenvalue, so 2 minus lambda into 5 is eigenvalue. 5 minus lambda is a factor. 4 equal to lambda, so 4 minus lambda is factor. You can say lambda minus 4 or 4 minus lambda. So because this is the characteristic equation, multiply them. This is lambda square. This is minus 7 lambda plus 10 into 4 minus lambda equal to 0. This is minus lambda cube. And again, this is minus, this is plus 7 lambda square plus 4, 11 lambda square. Again, this is minus 28 minus 10, minus 38 lambda. Again, this is 40. Hope correct. Hopefully correct. Lambda cube, 7 lambda square plus 4, 11. Then this is minus 28, minus 10 is minus 38 and 40. Now, A satisfies the characteristic equation. So, minus A cube plus 11A square minus 38A plus 40I is equal to 0. Now, multiply by A inverse. If you multiply by A inverse, to get A inverse, you have to multiply by A inverse. You get minus A square. If you multiply by A inverse, you will get 11A. Multiply by A inverse, A into A inverse is I. So, minus 38I. 40 into I into A inverse is A inverse. You want A inverse. So, 40 A inverse will be equal to A square minus 11A plus 38I. So, A inverse will be 1 by 40 of this. A square minus 11A plus 38I. So, where is which option correct? You can see. That is the question. Options for disturbance. Here it is. 1 by 40, A square, we got minus 11A, A square minus 11A, 38I. You can see 11 should be minus, 38 should be plus. 11 should be minus, 38 should be plus. You can see 11 minus 38I plus. This is the right answer. So this is the right option. Like this, you get question. Here again. Shall we stop here? Yeah, if you have anything to say, I'll give you time 5 minutes. You can speak to
Yes.
me openly. Open up. Every
Yeah.
day we'll speak for some. Okay.
Okay.
You know the shortcut for all ones.
Yes, ma'am.
So you can write this as 2 into some matrix. All ones. 2 common. This is 2 times 1, 1, 1. You know shortcut only for all ones. So this is like 2B, I'm calling.
Yes.
A is equal to 2B. I know B means all ones. For B, I know what are the eigenvalues. What are the eigenvalues for this, the shortcut? 3.
Zero,
How many
zero,
eigenvalues will be 0? As I said,
I-
anyone of you, do you remember? 0, 0, 0, 4.
Multiply.
3
Four.
zeros. Because
Hmm.
this is 4 by 4 matrix, 3 n minus 1 zeros. If it is 5 by 5, 4 zeros will be there. 5th eigenvalue will be 5. If it is 6 by 6,